Hello everyone. It's been a while since I went to Japan and been in self-quarantines for 14 days. Until now, situation is got worse and worse, and then I decided to shift the whole class to be mostly online. The live session that we gonna continuing doing from next week on Thursday morning, like when we have actual class, I would like to dedicate that time just for discussion and Q&A. If you listen to the talk that I recorded many times and you still unclear about any kind of detail and you want to get more explanation, or you want to do some hand-on together in a class, then we're gonna use that precious times that we can do together, like 1.5 hours a week to do it. Up until now, we didn't decide yet how to change the rubric of the class. I know that for sure maybe we cannot do the final exam anymore if the situation is postponed the whole system. In that regard, maybe we have to shift to do problem-based or project-based kind of examination. Anyway, I'm gonna keep update to you guys in Facebook group. See you around. So for this week, mainly I want to focusing on these two things. Previously we learned more and more about data structure, and I've always mentioned that good data structure is designed for some purpose, and mostly when you contain something, like have the container to contain the data. Another thing that you want to do is you want to searching for some information in that containers. In the same times, you want to have ability to sort something out, to arrange the data in that container that you created. Then after we learn about searching and sorting, then you will see the purpose of each data structure much clearer and the application of it in real life. So what is searching algorithms? Basically, searching algorithm is just used for checking or retrieving elements in the data structure. So thinking about array that you got, you can assign random number of it. You can, because like in the real life, user gonna be the person who take the input, key the input to the system. Then what you're gonna do is you, as a data scientist or maybe database admin, you need to searching for information and retrieve it out to print it out, making the report. So searching algorithm is very practical thing that you're gonna do in real life. And classically, like normally if you think about searching algorithm, then we're gonna compare the speed. If one algorithm can search faster than another's, then that's one gonna be much more popular. That's kind of simple logic. So thinking about this, if I'm asking you to find the number 6 in random data structure, what you're gonna do? So for example, for the first array that we found, they have some random number in some random order inside, like these images. So what happened is that if we're gonna use kind of like brute force, or you might say the common sense for searching, then okay, I'm gonna searching for number 6, so I keep checking array one by one for the left hand side to the right hand side. So that's gonna be very simple logic, and you just compare the number in the first index of the array and see, like, is that number 6? Oh no, okay, go to the next one. Is that number 6? Oh no, go to the next one. Keep doing it until you find number 6. But if the data structure is sorted, like you have number aligned from 1 to 9 or 9 to 1, is that gonna be efficient to searching for number 6 one by one from the left to right? You see, like if we keep searching that way and the number is kind of big number in that data structure, or number on the back end of data structure after sorted, then it's going to take much longer times than usual, than what it should be. So in this case, normally we should have better algorithms to take care of this. And the way that we're gonna do it is that we gonna do some searching algorithm that normally designed and specifically made for sort data structure. So thinking about searching algorithm, then basically we can divide it into two major classes. The first one is sequential search. The second one, mostly we're gonna call it interval search. So sequential search itself, what does this mean? It's like its name. So basically you're just searching for the information straightforward, one by one. Check every single element in the data structure until you find that value that you want. Simple logic, like left to right checking that we're talking about before. So the most common sequential search is called linear search. And the linear search itself is simply just check each element in data structure in just one single direction. If you decide to check the array from left to right, it just keeps going from left to right. If you decide from right to left, it's going to be right to left. There is no way around. You declare the direction of searching beforehand, like looking at this animation. Searching for number 33, what it's do is like compare each index in the direction that you declare beforehand. For this one, we declare it's going to go from left to right. Then in that case, it's going to take like some number of times until it's found 33. Good thing about this searching algorithm is don't care about the status of data structure itself. Is it randomly organized or not randomly organized? Is mostly going to take the same speed. And it's simple to implement. And thinking about it more and more, then I have a couple of questions for you guys to thinking about. Can you write down the pseudocode for linear search algorithms? That might be the thing that we can talking about in the Q&A session. Another thing, maybe right here you can pause the clip and then try to do it by yourself. I didn't give you the solution yet, but it's going to be very simple, and we can talking about it in Q&A session. So the next question is, how can we do linear search in linked list? Is this going to work out well or not? Okay. So thinking about it, and we were talking about this together, discussing about it, or maybe do some of the code writing together in C and Python in next Thursday. In practically speaking, in real life application, normally you're not going to see linear search, because most of the searching algorithms that we use now today is outperform linear search. As I say, it's look like, okay, linear search is easy to implement, but at the same time it's quite stubborn. If you have data structure or array that's longer, much longer than that, thinking about linked list of like million node, or the data in Google that they contain in some size of trees, like a billion node inside. If you do linear search, it's gonna take you forever. So it should have better way to searching for information that you want. So the basic idea is come to the interval search algorithms. Interval search algorithms basically aiming for and only for sorted data type. So look at it here. I double quote it here, and please keep it in mind. Or these searching algorithms mainly made for sorted data type and sorted data type only. Why? Simply because if it randomly organized data structure, then I would say like there is no specific way for us mathematically to declare the function that can fasten the searching algorithm more than linear search. However, if we can sort the data in one direction, like either from like descendant or ascendant, Anyway, it's going to help you a lot to create some specific interval function that can fasten the speed of searching algorithms. So the most common one that used a lot in computer science is a binary search, and mostly embedded in all searching function of most programs that you use. For example, in Microsoft Excel, when you placing the Control F and then finding some value, they also use binary search inside. So the binary search, how it works? Simply speaking, you have long line of array. For example, the way it does is find the middle point of array first, then compare the value. If that value is less than the value that we're looking for, is go for the bigger half. If it's more than number that we're looking for, is go for the lower half. That's kind of simple. Then you find the middle point again, and you compare left and right, and you find another middle point again, and again, and again. It's simply an divide and conquer algorithms that you divide the search space in half, then another half, and another half, another half. Then mostly you're gonna use like much fewer iteration before you're gonna find the searching value. So look at this animation. This one gonna show the comparison between binary search and sequential search. Okay. Yeah, look at it again. So yeah, again, from the starting point, you can see that binary search, the way it does is find the middle point and make a comparison and go to another place. So in this case, to find number 37 is used only 3 times. Okay, go to this middle point, then divide another one in half, then divide another one in another half, and then you got it. Okay, for sequential search, it takes 11 steps before you're gonna find this number. Thinking about it more, if the data is much bigger than this, how it's gonna be? It's simply being that binary search cut down times more than half. It's more like faster in the logarithm function. I think you're gonna learn about how to calculate the effectiveness of algorithms together with Ajahn Isarapong in algorithm class. So I'm not gonna talking so much about this. However, what is the worst case scenario for binary search? You can take time here thinking about it. This is a solution. Thinking about worst case scenario, so you need to think about the best case of sequential search. So what is the fastest searching time for sequential search? Simply speaking, the data that we're looking for is the first data in array. So it's gonna look like this. You're searching only one time, you found it. However, for binary search, you need to cut the data type down in half, and another half, another half, and another half, until you reach the first data or the back data of data structure. That's gonna be the worst case scenario. But then in most of the case, and mostly the best case scenario, is that if the data itself is the last one in the data structure. So looking at this here, or in the middle one, that's gonna be the best case for binary search. This one gonna take like half of the size of data structure for searching for that. So you can see that binary search, if you're sorting the data ascendant or descendant, it's going to be much faster than sequential search in most of the case. It still have some flaw, have some worst case scenario, but good enough and not hard to implement at all. So thinking about it a little bit more, I would like you guys to try to write down the pseudocode of binary search algorithms, or flowchart, or anything that can declare the algorithm itself. Then we're going to talking about it and see the solution together in the Q&A section. And then the last thing that I would like to give you like some thinking, like thought-provoking thing can we apply this binary search in linked list? Is the binary search only made for array structure only? Thinking about it, and then we're gonna talk about it later in the Q&A session this Thursday. So I would like to end the first half here at the searching algorithms. Then we're gonna continue the second half, mainly focusing on sorting algorithms. And that's it. Thank you for this time and see you around. Bye bye.